In this video, we are going to look at the concept of work. So this is a part of the chapter 2 of the physics, ICSE physics. So work, energy and power. So let me begin with the concept of work. The work is, every day we will see the concept of work. From morning till evening, we will do so many works. Okay? So it's not unfamiliar to us, but it's a very familiar term. But the thing is that in physics, the definition of work is completely different from our natural understanding. For example, some of the work that we do in everyday life may not be defined as work in physics. So we will see the definition of work to begin with, and then we will understand what exactly physics defines work, and then we will take some examples and we will understand the concept. A work is said to be done on a body by the application of the force if that force displaces the body by a distance. So let us understand here. There are two things. One, there is force and there is body. So the force is applied on the body. When the force is applied on the body has to move. Only then we will say that if work is done. For example, take this body. This is a body and I have applied a force, and then the force should have to move this body in by some distance, then we will say that work is done in that case. Okay, the natural question is, what if there is no displacement? Then can we say that the work is done or not? We will say there is no work done. For example, if I have a wall and then a boy who is there pushing against the wall, does the wall move? Obviously no, it does not. Then can we say that work is done in that case? No. According to the physics, we will say the work is not done. But in reality, do we say that work is done? Yes, we will say, oh, I have done a lot of work. But according to the physics, that is not the case. So this difference between a common understanding of work and the physics point of view needs to be understood. Let's take some examples. For example, pushing a cart. In this case, is the work done? Yes, work is done. For example, if I take the cart and then if I push it, am I applying a force? Yes, force is applied. Then is the cart moving? Yes, cart is also moving. So if the cart is moving and the force is applied, then the work is said to be done. So displacement is, we will denote it by S, and the force we will denote it by F. Let's talk about the pushing of a wall. So is the force present in the pushing of a wall? Yes, I am applying a force on the wall. Is the displacement present? No, the displacement is not present. So it is not, we will say the work is not done in this case. Let's talk about the reading. Is the force present in reading? Maybe. We may not see it very obviously. So let's take force is not present because I am not applying any force there. And then I will say displacement is there. No, there is no displacement. All I am doing is I am looking with my eyes and then reading. I am not applying force on anything, and nothing is also moving there. The book is not moving or the letters are not moving. So we will say that even in this case there is no work done. So these are the cases, and this is the understanding of the concept of work from the physics point of view. Now let us see, work is a scalar quantity. So you might have already read about two quantities, one is vector, another one is scalar. The difference between a vector and a scalar is vector has both magnitude and direction. So vector has both magnitude and direction. So this is a vector. Whereas a scalar has magnitude but not the direction. So these are the two types of physical quantities. All the physical quantities will be divided into two sets. Some are called vectors and some are called scalars. Vector is one which has both magnitude and the direction. Scalar is one which has only magnitude but not the direction. So does the work have any direction? When some work is done, do I say that, oh, I have done work towards north, I have done work towards east? No, we will never say that. So that means work is a scalar, but we cannot give any direction to the work. Similarly, what is the SI unit of work? SI unit of work is joules. And then CGS unit, what is the CGS unit? CGS unit of the work is ergs. So erg is a term which came from Greek word which is called ergon. Ergon means doing work. So that is where the CGS unit came. The CGS unit is erg and it is joules. So these are very important because we will get this as a one marker in your board exam. Then, okay, I have done a work on a particular object by applying a force. Then what is the amount of work that I have done? We need to sometimes have to measure that amount of work. So how do we measure the amount of work? Is there any formula in physics? Yes, of course. Physics is all about measurements. So then we have obviously a formula. What is the formula? Work done is always given by force and the displacement. That means if I displace the body for a longer distance for a given force, then my work is more. Obviously, if I push a cart to only 10 meters versus 20 meters, I will have to spend more and more work. I will be doing more work in pushing the cart to 20 meters than in 10 meters. So the amount of work, the magnitude of work depends upon two factors. One, force. Two, the magnitude of the displacement. If the force is more, then my work will be more. If my displacement is more, in that case also my magnitude of work is more. Okay, good, fine. I am applying a force in this direction and the cart is also moving in the same direction. Here let us talk about the direction of the force and the direction of the displacement. What if my force and the displacement are not in the same direction? Is it possible? So yes, we will take some examples. For example, this cart, I can either just push it and then it will be moving in this direction. In this case, both my force and my displacement, both of them are in the same direction. But sometimes you might have seen people will also pull the cart. When they pull the cart, it is possible that the force is applied in this direction and the displacement will be in this direction. And both of them are not in the same direction. They are at an angle. Let's say the angle between the force and the displacement is theta. Then if both of them are at an angle, is the magnitude of the work same? No, it is not same. There is a different formula for that. What is the formula? The work done in that case is given by F multiplied by S multiplied by cos theta. So it is called Fs cos theta. So there are two formula. One is F multiplied by S, that is when force and displacement are in the same direction. And there is another formula, if force and distance are at an angle, the work done is given by F multiplied by S multiplied by cos theta.